I'm Anil Kumar. In this video, I'll take up 3 examples. So we are actually taking 3 examples on optimization. Here's the first one, which is number based. The other two are to find, will minimize area, will minimize and maximize area in the other two. So we'll take area of a window to maximize the light and minimize the cost of paper by minimizing its area, correct? So that's the whole idea. One important thing here is to understand all these steps involved. In most of my videos, we have done kind of shortcuts at places. Now here I'll go in all steps to explain you how to solve any optimization question in calculus. The question here is, the product of two positive numbers is 288. Minimize the sum of second number and twice the first number. So first step is define variables, right? So first let's define variables. So we select the two numbers p, x and y. So we are talking first and second, so we'll select first number bx and second by. Now it says the product of two positive numbers is 288. So we get our equation 1. Since we have two variables, we need two equations. Okay, so we need two equations. So our equation number 1 is product of two positive numbers is 288. So we get x times y equals to 288. And from here, you should always relate one in terms of the other, right? So that is kind of a must. So you do y equals to, let's say, 288 over x. So what we did here was, from our equation 1, which we defined, we isolate variable. So you can say isolate one variable. It is your choice. You could use x or y. Now, the second statement will give a second equation. Minimize the sum of second number and twice the first number. So we need to minimize the sum. So let us say sum is s for us. Sum of second number and twice the first number. So second number is as such, which is y plus 2x. So that is our second equation. And we have to use this equation to find the two numbers x and y which meet the criteria. The criteria is to minimize their sum. Sum is first number as such and twice the second number, right? So that becomes the criteria. Second number is as such and twice the first number. Now from our equation, we could write y as 288 over x. So we are now going to replace it with this. So we get sum as equal to 288 over x plus 2x. Now you can see that we have equation in one variable. So we have equation in one variable. So at this stage, you can find first derivative and then critical number. Critical number is when the first derivative is equal to 0 or does not exist. So both actually are critical numbers. Okay. Also, when you're working on this, you have two positive numbers. You could say here that both x and y, you could say x and y are greater than 0. So that becomes a boundary condition, which is good to know when you begin your solution. Now, first derivative, that means we'll differentiate the sum with respect to x. So you get minus 288 over x squared plus 2. To get the critical number, we are going to equate this to 0, right? So we'll equate this to 0 to find our critical number. So that gives us that 288 over x squared is equal to 2. Rearrange and find x. So what we get here is, let me do it on the right side. So what we get here is that x squared is equals to 288 over 2, which is 144. So x is equal to plus minus square root of 144. Since we know x is greater than 1, so it has two answers, which is negative 12 and plus 12. And since we know that x is greater than 0, that is not valid. So the valid answer is x equals to 12. So x equals to 12 is critical number. Perfect. Now, the question is to minimize. How do we know that this really represents minimum? So for that, we actually have two types of tests. We could analyze the first derivative, that is ds over dx in this time, or we could find the second derivative, right? So that is d2s over dx squared. So both can give us condition or proof that this is indeed a minimum, right? So if I find second derivative, this is my first derivative, what do I get? Let me do that. So this derivative here, let me write this first, which is 2 minus 288 over x squared. The second derivative will be minus 2 times minus is positive, so we get 2 times 288 over x cubed. And we know this derivative is always greater than 0. And when this derivative is greater than 0, the curve is concave up, right? And that means we are looking for minimum. So I hope that is clear. So you do get minimum from the second derivative test. Let us also analyze the first derivative to do the needful. So our critical number here is the number 12. Now we can take a test number on either side, let's say 10 and 14. And if I substitute the value here, so if I write 10 here, 10 square is 100, correct? So 10 square 100 means this is, if I divide by 100, I get 2 minus 2.88. Do you see that, 2.88? So you get a negative answer. Since you get a negative answer, rate of change is going to downwards, correct? Now if I take 14, so 14 square, 288 divided by 14 square will give me a number lesser than 2. So I get a positive answer. We don't really have to find the answer. We have to just check the sign. So we get negative for 10 and positive for 14. You can use the calculator and verify. And that clearly indicates that we are looking for a minimum. Is it okay? So either test could be done to really get your solution. Now, the question here is to find both the numbers. We know that x is equal to 12, and we also know the relation between x and y. The relation is right there. So we can write what y is. So y is equals to 288 over 12. And that is, you can just divide by 288 and get it. So it is 12 times 2 is 24 and 48 is 4. So the other number is 24, correct? And so we can write down our answer as the two numbers are 12 and 24, correct? So that is how you should be doing it. I'd like you to watch the other two videos also, which are more geometry based, and understand how we can actually do optimization questions in calculus. Thanks for watching and all the best. The question here is, a rectangular page will contain 24 square inches of print. The margins at the top and bottom of the page are 1.5 inches wide. The margins on each side are 1 inch wide. What should the dimensions of the page be to minimize the amount of paper, right? So let's sketch a diagram. So let me make a rectangular page first, and then we'll write down the margins. So let us say this is the rectangular page, and print area is something like this. what we are given here is that top and bottom margin is 1.5. So this is 1.5. Okay. And on the sides, we have 1 inch, right? So all these dimensions are in inches. Okay. Now, let us define variables for the print area. Let me take x and y as the variables. So let us say this is x for us and this is y for us. So that is a print area. So y is actually this much. And x is this much. Okay. Okay. So that means total length you can say is x plus 3, correct? And width is y plus 2. Perfect. So that becomes the width, correct? So from this particular diagram, we can always write what area is. Area is equal to x plus 3 times y plus 2. Perfect. So y plus 2, let me write it here. And this is, let me write here, x plus 3. So that is one equation which we have. We can always expand and simplify this one. Second, we are also given that print area is 24. Now, if the print area is 24, that can help us to relate x and y. Correct? So let's say 24 is the print area, which means x times y. Since the print area is right in the center, that is a print area. So this print area is x times y. So we are given that x times y is equal to 24. So that helps to relate these two variables, and we can write what y is in terms of x. That's it. So once we know that, we can replace this value in the equation and get area in one variable, which is x for us now. So y is 24 over x plus 2. Let's expand this. You could use a product rule to find derivatives, but it's simpler to expand and then do. So if I multiply by x, I get just the number 24 plus 2 times x. If I multiply by 3 times this is 72 over x, and 3 times 2 is 6. So we get all these terms here. Now, let us find the derivative. So 24 plus 6 is a constant. Its derivative is going to be 0. We are finding derivative with respect to x. So 0. And so the derivative of 2x is 2. And this will be minus 72 over x squared, correct? Yeah, you could actually combine, right, 30 here. Anyway, so that becomes the derivative. And for a critical number, this should be equal to 0. So in all optimization questions, we have to find the first derivative, equate it to 0 to get the critical number. So this is for critical number. So that gives you the value for x. So you could write this as, we'll do it in 2 steps, equals to 2, or that implies x is equals to square root of 36. So that could be plus or minus 6. We have dimensions, so we know x has to be greater than 0. So we'll take positive value 6 as our answer. Correct. So what we have done so far is figure out the critical number x. Now from here, we have to analyze whether this critical number is going to give us maximum or minimum, right? It could, or neither. It could give us anything, correct? So we could do by analyzing the second derivative, or by analyzing the first derivative, either way. So I'll follow both the approaches. One, we can do second derivative, which is simple. So d2a over dx squared will be what? Derivative of 2 is 0, and this is, it becomes positive 72 over x cubed, and derivative of this is minus 2x, so times 2. Correct? So minus and minus makes it positive. So what you notice here is that the second derivative is greater than 0 for any value of x greater than 0. Correct? So that really means that the critical number is minimum. So we are talking about minimum area that works. How to analyze the first derivative? We could do that also. So we have dA dx. Let me show it here. So dA dx, the critical number is 6. You can take a test value on either side. So if I take a test value, let us say we have a test value of 4 and let's say 7. dA dx is 2 minus, dA dx equals to 2 minus 72 over x squared. Now if I write a value, which for 6 it is 0, right? So if I write a value 4 here, then 4 square is 16, and when I divide this by 16, I get a number which is more than 2, right? Which is 4, and therefore it is going to be negative. So for a value 4 will get a negative. But if I write 7 here, 7 square is 49, and 49, when you divide 72 by 49, you're going to get less than 2, right? 49 twice is more than, is 98, right? So it is less than 2. So you get a positive value. Positive value will give me increasing rate of change, and that indicates a minimum. So it is very important when you solve optimization questions, first to make a diagram, relate variables, find equations. Once you have the critical number, you have to show why it is maximum or minimum, correct? And then you can write your answer including the units. Units are in inches. So we got the value of x as equal to 6. Let's find what y is. So x is equals to 6, y is equals to 24 over 6, which is 4. And therefore our answer is that the dimensions of the paper. So what should the dimensions of the page be? So dimensions of the page is how much? Let me find dimensions of the page. That is the dimension of the page, right? So the dimension of the page is x plus 3, which is 6 plus 3, by y plus 2, which is 4 plus 2. Is it okay? So it is 9 by 4 plus 2 is 6. 9 by 6. And all are in inches. So let me write like this, inches, right? So that is inches. So we have 9 inch by 6 inch paper to minimize the cost of printing. So I hope the steps are clear. We have general formula for optimizing light through a window. The question here is, determine an expression for maximum light through a window which has a rectangular base with semicircle on the top for given perimeter. So we are given perimeter, we need to maximize area, that is. So maximum light means we have to maximize area. So that's the question for us. So what should be the dimension which relates this maximum area with the given perimeter? So let's sketch one. We want circular, semicircular top on the window, which is kind of like this. Let's make semicircular. And then we have a window here with rectangular base. So that becomes the rectangular base for the window. Now, let us say that this radius is r for us, for the circle, right? So, or we can say x for us. Let's make it x. We'll turn x and y. So if this is x, then our length could be 2x. Let's take width as 2y. Okay. So that becomes the dimensions which we are looking for. We have taken twice x as the length and twice y as the width. So at the end, remember, if you find the value of x and y, you have to multiply by 2. We did this so that we avoid fractions. That's the whole idea. Perfect. Now, whenever you're given this kind of a situation, perimeter means outside only, so do not include this bar in between. So let's write down an expression for perimeter of this window. So perimeter will be, there is one length of 2x plus there are two windows heights, 2y, 2y, that makes it 4y, plus half the circle, which is half of 2 pi r, which is 2 pi r as x for us. Good. So that becomes the perimeter. Now, area is area of rectangle and the semicircle. So it could be written as 2x times 2y times, that's the area, plus half the area of the circle, which is pi x square. So that becomes the area. Now we could write this as 4xy plus half pi x square. Now this equation is in two variables, x and y. We need to write only in one variable. So here we have 4y in the perimeter term, which we can isolate, correct? So let's do that. So from this equation, what we can do is we can write what 4y is, so we can combine these two terms, right? That becomes simpler. So we know 4y is equal to perimeter p minus 2x minus this cancels pi x. So that is the expression for 4y. We'll replace 4y with this value, and then we can write area as function of x as x times, so instead of 4y, I'm writing all this, which is p minus 2x minus pi x, correct? And we already have half of this circle area, correct? Now let's expand this and simplify. So we have p times x minus 2x square minus pi x square plus half pi x square. Now minus pi x square and plus half, we could simplify this further and write this as px minus 2x square minus half pi x square, correct? So what we get here is area as a function of x, correct? So that is an expression which we can work with to maximize the area for the given perimeter. Now to maximize, we have to find the critical number. So now let's find the critical number. To find critical number, derivative should be 0, right? So we'll find critical number. That is to say, let's differentiate with respect to x. So we get dA over dx is equal to, we get p from here minus 4x, and this is 2 and 2 cancels, pi x minus pi x. So that is what we get. So p minus 4x minus pi x is the first derivative. Critical number is when that dA dx is equal to 0. So we'll equate this to 0 to find the critical number. So we can write from here that the value of x should be what? So we can isolate x from here, right? So taking x common, we can write this as p minus, let's take x common. So we get 4 plus pi equals to 0, or we can say x is, equals to p divided by all this. Is it okay? So x is equals to p divided by 4 plus pi. So that becomes the value for x. That is the critical number for us. So what we found here is that the critical number is x equals to perimeter divided by 4 plus pi, right? So that becomes the value of x. Now, if x is equals to this, do we get maximum or minimum? How do we show that part, right? So that is another question which we have to address. We already know that the first derivative, dA dx, is equal to p minus, we can write this as p minus x times 4 plus pi, correct? 4 plus pi is a constant. So let's find the second derivative. Second derivative of this will be p is a constant, and so we get minus of 4 plus pi. So for any value, for it is negative, right? So we say it is less than 0. So less than 0 second derivative means that we have maximum for critical number, right? Is that correct? So those of you who haven't done second derivative test can also analyze the first derivative. So let me do that. So I'll adopt both methods since some students have not done this. So let's analyze dA dx, the first derivative, correct? So we have our critical number, which is perimeter over 4 plus pi. The expression for dA dx is p minus all that. P is a constant, correct? Now, we know that dA dx is equals to p minus x times 4 plus pi. So at critical number, it is 0. So if I take a value of x, which is less than this, so if x is less than p over 4 plus pi, in that case, we get a higher value, right? If this is less than this, then p is bigger, correct? So this is a higher value. So we get a positive answer, correct? So in that case, we get a positive answer. However, if I take a value which is more than this, for this value it is 0, right? So if I take x greater than p over 4 plus pi, in that case, this will be negative, and so we will get the derivative as negative, and that also shows maximum. Is it okay? So either way, you could show that the x value of p over 4 plus pi will give you a maximum, correct? So that is one thing. Now we know what x is. We can find what y is from this given expression. So let's calculate y from the expression which is right there. Let me circle this. Right. So let's find what y is. So y will be equal to 1/4 of, this is 4y, 1/4 of perimeter p minus 2x minus pi x. We could write this as okay, so let me take x common here, right? So we get x common, we get 2 plus pi, correct? Now if I substitute x as p over 4 plus pi, what do I get? So I get 1 over 4 times perimeter minus. So instead of x, I'm writing p over 4 plus pi. Is it okay? And we have 2 plus pi here. So we can actually take common denominator and solve this out. So what we have is 1/4 of 4p plus pi times p minus 2p minus pi times p divided by 4 plus pi. Is it okay? So that is the value of y. So 4p minus 2p gives me, this is 1/4 of 4p minus 2p gives me 2p. So we get 2p. And here we have pi p and pi p which cancel out. So we have 2p over 4 plus pi. Is it okay? 2p over 4 plus pi. So we could always cancel this and simplify it further, right? So which is, let me just squeeze it in here. P over 2 and this cancels twice 4 plus pi. Is it okay? So that is what we get. So we just cancel this and write 2 here. Correct. So what we really got is the value for x and y, correct? So as I said, the dimensions is 2x and 2y. So let me write down our answer here now. Okay. Let me put it a circle. Let's say this is the space in which I'm going to write down my answer. Okay. So what we get here is our dimensions are 2x. So what is 2x equals to? Twice this, right? So it is 2p over 4 plus pi. 4 plus pi. Is it okay? And 2y is equal to, let me multiply this pi by 2. This 2 will cancel then. So it is p over, so this 2 will cancel 4 plus pi. 4 plus pi. So that gives me the dimensions for the window, which will have maximum area for the given perimeter. Perfect. So I hope that makes sense. So if you know the perimeter, you know the dimensions of your window, which is going to give maximum light through it. So it's a very important question from test point of view. I'd like you to go through it once again, understand the concept. Feel free to make suggestions and your comments. If you like and subscribe, that would be great. Thanks for watching and all the best.